So good morning children. So last class we have completed the chemistry lesson chemical bonding. Okay. So today we are going to start the new lessons physics. Okay. Electric charges and electric current. Okay. Electric charges and electric current. So what is mean by electric? Okay. And what is mean by charges? Okay. Charges means what ma? Particles. Okay. Charges means what? Particles. Okay. So electric current. Electric current. Okay. So what is the meaning about electric charges and electric current? Okay. So all this information we are going to study in these lessons. Okay. So before entering into these lessons, okay. So what is mean by fundamental quantities and what is mean by derived quantities? So length, mass, time, temperature, amount of the substance, okay, electric charges. Okay, so these quantities are called fundamental quantities. Okay, fundamental quantities and fundamental properties. Okay, so these matters are present in where? All type of substance. So matter is made up of what? Atoms and molecules. Okay, so molecules are made up of atoms. Okay, so atom is made up of what ma? Smallest particles. Okay, so this much information we have learned from the lower sections. Okay, so electric current. Okay, electric current and electric charges. Okay, so an electric current consists of what ma? Moving of electric charges. Okay, electric current consists of what? Moving of electric charges. Okay, so next one. So what is mean by electric charges? Electric charges. So if you are taking an atom, so atom consists of what? Okay, subatomic particles. So atom is made up of what ma? Subatomic particles. Okay, so inside the nucleus, proton plus neutrons are present. So proton what charge? Positive charge. Okay, neutron, okay, no charge. Okay, so around the nucleus, okay, which is revolving, so electrons are revolving. So what is the charges of electron? Negative. Okay, so negative. Okay, so how to find the charges of electric current? Okay, so because of the particle, charges are created. So we cannot remove the protons from the nucleus. Why? Because the nucleus, okay, is made up of proton plus neutron. So the proton is present center part of the atom. Okay, center part of the atom. So electrons are present in where? Outside part of the atom. So we can remove the electrons from easily, okay, than the protons. Okay, so we may give slight amount of the energy. We can remove or add the electrons. Okay, but the protons we cannot remove very easily. So the charges are current based on what ma? Moving of the electrons, not moving of the protons. Okay, suppose if you are adding one electron to atom, okay, that atom contains what ma? Negative charge. Okay, if an electron is removed from an atom, okay, and becomes positive charge. Okay, if you are removing the one electron from atom, becomes what charge? Okay, so removing means a positive charge. Okay, adding, so what charge? Negative charge. Okay, adding means a negative charge, removing means a positive charge. Okay, for example, if you are taking the comb, okay, you have to rub with our hair. So what will happen? Okay, okay, hair contains what ma? Some particles. Okay, so due to the rubbing, okay, the electrons are transported from hair to comb. Okay, so at that time our hair is acting as what charge? Positive charge, because loss of electron. Comb acting as a negative one because gain of the electrons. Okay, so after rubbing the comb, we may take bring to the near the piece of papers. Already we made it as a small piece of papers. Okay, the piece of papers attracted by what ma? Comb. Okay, the comb are attracted by the small pieces of paper. So in this way we have to prove what ma? Charges. Okay, so next one, measuring of electric charges. So how to measure the electric charges? Measuring of electric charges. Okay. So electric charge is measured in coulomb unit. Okay, yes, electric charge is measured in what unit ma? Coulomb. So what is the spelling for coulomb? C-O-U-L-O-M-P. Okay, C-O-U-L-O-M-P. So what is the symbol of coulomb? Capital letter C. So what is the unit is used to measure the electric charges? What is the unit? Coulomb. What is the symbol of coulomb? What is the symbol of coulomb? Capital letter C. What is the spelling? C-O-U-L-O-M-P. Okay, the charge of electron is numerically very small. Okay, the charge of the electron is numerically what ma? Very small. Okay, very small. Okay, and represented as E, that value is equal to 1.6. Okay, 1.6 into 10 to the power of minus 19 coulomb. Minus 19 coulomb. Okay, the charge of the electron. The charge of the electron represented as E. The value of E is equal to 1.6 into 10 to the power of minus 19 coulomb. Okay, so this indicate any charge, okay, has taken to be integral multiple. Okay, any charge has taken to be integral multiple n. Okay, integral multiple n of this fundamental quantity, fundamental unit of electric charges. Fundamental quantity means what mark here? Fundamental unit of electric charge. So okay, so therefore Q is equal to N into E. Q is equal to N into E. So okay, so what is the meaning about Q ma? Any charge, okay, any charge is equal to what? Integral multiple of this fundamental unit of electric charge. Okay, integral multiple, either whole number, either 1, 2, 3 or 4, 5 with the fundamental unit of electric charge is equal to what ma? Any charge of the substance or particle. So in this way we will measure what ma? Measuring of electric charges. Okay, so different types of coulomb values we are using in our day-to-day life. Okay, different types of coulomb values are we are using in our day-to-day life. So 1 microcoulomb, okay, 1 microcoulomb is equal to 10 to the power of 6 coulomb. Okay, 10 to the power of minus 6 coulomb. Okay, 1 microcoulomb is equal to what ma? 10 to the power of minus 6 coulomb. Okay, 1 nanocoulomb is equal to 1 nanocoulomb is equal to 1 nanocoulomb is equal to 10 to the power of minus 9. Okay, here no need to use the coulomb value. Okay, coulomb unit no need to use. So 1 microcoulomb. So here we are using coulomb. So here no need. Okay, 1 microcoulomb is equal to 10 to the power of minus 6. 1 nanocoulomb is equal to 10 to the power of minus 9. Okay, 1 picocoulomb is equal to 1 picocoulomb is equal to small letter P, capital letter C. Okay, is equal to 10 to the power of minus 12. 10 to the power of minus 12. Okay, so these are all the values we are using in different way. Okay, so what are the values ma? 1 microcoulomb. Okay, 1 microcoulomb is equal to 10 to the power of minus 6. Okay, 1 nanocoulomb is equal to 10 to the power of minus 9. 1 picocoulomb is equal to 10 to the power of minus 12. Okay, units of electric charges. Okay, suppose some of the textbook, okay, here coulomb also it is given. Okay, we may use the coulomb also, it is not a problem. Okay, so next one. Okay, so electric charge is in a additive in nature. So electric charge is in a additive in nature. So additive in nature means what ma? Okay, it is the one of the factor to determine charged particles. Okay. The total electric charge of the system, the total electric charges of the system is the algebraic sum of all the charges located in the system. For example, one system contains two different charges. Okay, so plus 5c. Okay, another one value minus 2c. Okay, one system contains two different values. Okay, plus 5c minus 2c, another one value. So what is the total value of that system? Okay, so plus 3c. So we have to minus 2c. Okay, so in this way we have to find out the electric charges value. Okay, next one, electric force. So next one, electric force. So what is mean by force? So already we know what is mean by force. Force is nothing but what push or pull action of any object. It's nothing but what force. Okay. So here electric force. So in the electric force, how to define the electric force? Okay, the forces existing between the two charged particles. Okay, the force existing means what already available. Okay, the force existing between the two charged particles. Okay, two charges is called what electric force. Okay, for example, plus and minus. Okay, in between, okay, the force existing. Okay, so that is called what electric force. Okay, that is called electric force. Okay, so two different types of forces are there. One is attractive, another one is repulsive. Okay, so what like charges. Okay, like charges repel with each other. Unlike charges attract with each other. So already we have learned this concept in lower sections. Okay, so like charges means one same charges, minus plus. Okay, unlike charges means what minus plus or plus minus. Okay, so these two unlike charges. Okay, so these two like charges. Okay, so like charges repel with each other, unlike charges attract with each other. So the electric force will happen in what type of charges? Okay, so when the charges are not in contact. Okay, not in contact means what like charges. Like charges or unlike charges? Okay, unlike charges means contact will be there. Okay, plus and minus it will attract. Okay, unlike charges. Like charges means it will not attract or not in contact. Okay, so the electric force, how to define the definition for electric force? The force existing between the two charges is called electric force. Okay, next one, electric field. Next one, electric field. So what is the symbol of electric field? E. What is the symbol of electric field? E. Okay, if you are taking the one charged particles, positive, okay, some of the forces are acting, okay, towards to the positive charges, okay. So how to represent it in the electric field of lines. Okay, the electric field of lines is nothing but the electric forces are acting either in the straight or in the curved path. Okay, the electric forces. Okay, so we are representing in the form of electric field. So we are indicating, okay, the forces are indicating here lines. Okay, so electric forces of lines either may be straight or in the curved path. Okay, straight in the curved path along with a unit positive charge tends to move in the electric field. Okay, so in this way we will define the definition for electric field of lines or electric field. So what is the definition for electric field? Okay, the electric field of lines of force are straight or in the curved path. Okay, along with a unit positive charge tend to move where ma? In the electric charge, in the electric charge. Okay, so if you are taking the isolated positive atom, okay, the same way isolated negative atom. Okay, isolated positive atom. Okay, for an isolated positive charge, okay, the electric lines are forces are readily outwards. Okay, positive means outwards. Outwards means we have to draw the arrow mark in this way. Okay, center to outside. Okay, if you are taking the isolated negative charge, okay, inside. Okay, inside. Okay, so in this way we have to represent what my electric field of lines of force. Okay, electric field of lines of force. Okay, so how to find out the strength of the electric field? How to find the strength of the electric field? Okay, how close to the field of the lines? Okay, suppose these lines are very close, so we can assume, okay, the electric field of the lines of forces are strength. Okay, suppose these lines are maintaining the gap, okay, so we may consider as what ma? The electric field of lines is not strength. Okay, so next one, electric potential. Electric potential. So electric potential. So what is meaning about electric potential? So what is the definition? So potentials means what ma? Something have done, something what to be done on a positive charge. Okay, that is the definition for what ma? Electric potential. So electric potential is a measure. Electric potential is a measure of the work done on a unit positive charge. On a some work done should be done where? On a unit positive charge to bring it to the point of the against all the electric forces. Against all the electric forces. Okay, this is the definition for what ma? Electric potential. Electric potential. Okay, next one, electric current. Electric current. Okay, usually, okay, the flow of the electrons, from what potential to what potential ma? Higher potential to lower potential. Okay, higher to lower potential. Okay, so electric current. Okay, so that's all. Today classes is enough. Okay, the remaining part we will see in the next class. Okay, so today homework. What is the homework? Okay, so already we have given the continuous question number 39. Okay, 36, 37, 38, 39. Today 41. Okay, so what is Coulomb? What is C-O-U-L-O-M-P? What is Coulomb? Okay, next one, define electric force. Define electric force. Okay, 42, define electric field. 43, define electric potential. Define electric potential. So 4 questions are the homework for you. Okay, so thank you children. So remaining part we will see in the next class. Okay, so thank you.